Welcome back to Tech Tips, Fixes and More. My name's Ron, and today I'm going to be working on some more Bose equipment. So it's interesting that I've been getting a lot of Bose equipment. I'm not sure why that is, but it's interesting stuff to work on, and fortunately I've been able to get schematics and other information on them. So happy to do it. The last one I did was a Bose L1 system. Sometimes they call it the stick, and I think they call this one the stick as well. This is a newer model. It's an L1 Model 2. It has a little bit of different setups to it. It's got the base here is smaller, but it has legs that extend out to give it stability. It comes with a subwoofer and the typical stick that stacks up one on top of the other. I haven't put this together to test it yet, and I'm thinking I'm going to check this base, which contains the power supply and some other circuitry. So I'm going to start with this, and we're going to see what's going on. Interestingly, I expect to get another one of these in any day now, and so we may have another video after this one that looks at a very similar unit. So we're going to jump in here and we'll see what we can find out. So here are the symptoms that the owner told me he experienced with this. He plugged it in and it actually was sounding good for about 5 minutes. Apparently he had plugged in a microphone or a guitar or some kind of signal source, and then it started to distort, and he also heard static noise in there. He plugged straight into this unit here. Before that he was going through a mixer, and so he plugged straight in, and he got exactly the same result. So that's all I know about it from that. And so I'm going to have to do some testing to see what actually is going on with this. I've got the base set up, and I've added one segment of the speaker column to it. When you slide this in, it actually makes contact with the connector in there, and if you add the other one, it slides in from the top and makes connection as well. Now, in order to ensure that this thing is stable, these legs, they actually fold out, and you actually can't insert the speaker until they fold out. So if you're not familiar with these, that's how they work. I've got my signal generator set up and connected into the analog input on here. I've got it plugged in, and I'm just going to turn on the power here. As far as I know, it's safe to just switch it on, which isn't always the case with some power amps, but I think we're all right to do this in this case. So here goes. We're going to turn it on. The power / fault light, which is back here behind the speaker, turned blue. I can hear a slight hum, but nothing objectionable. There's a trim adjustment on the back here, which I'm going to turn all the way down to 0, and then I'm going to turn on the power to my signal generator. And I'll bring that trim up, see what we get. When I go past about midpoint in the trim adjustment, I get the signal / clip light coming on green, and I think it won't. I think after you actually get into clipping, it'll probably change to red, but I'm not sure how much I want to turn this up right now. When I turned it all the way up, it stays green, but I couldn't hear any clipping anyway, so I don't think we have a problem with that. So what I'm going to do is I'm going to put this signal on here, and I'm going to leave it for a few minutes because the owner said that it ran fine for a few minutes and then it started to cause a problem. So I think all I can do right now is try that and see what happens. Okay, I've only run it for about a minute or so, and this is what started happening. When I turn the signal up to a certain extent, it cuts in and out. When I turn the signal down all the way, it just does that high-pitched whistle. The power/fault light is flashing red in time with this sound. So I'm going to guess it's something in the power supply or the amplifier is breaking down, but it's oscillating. Now usually these things have some kind of a switching power supply, and that would possibly explain why this isn't just a 60 cycle hum. On an older style amplifier, if you're getting a bunch of noise out of the power supply, it's going to be most likely 60 hertz or some multiple of that. This is quite a bit higher, which would suggest probably the oscillating frequency of a switching power supply. I'm guessing at that, but that's what I would say is the most likely thing. So the next thing I think is to shut things off and take this apart and get a look inside and maybe measure some of the power supply voltages and see what happens. Okay, so let's get this thing open and see what we've got here. So I don't see anything obviously burnt. I don't see any bulging caps. Nothing obviously on here that has been hot or burnt. I can't see the backside of the board. I may have to look at that later, but this kind of a problem, I wouldn't expect catastrophic, obvious visual problems, but it's important to look anyways to start. So I think the next step is to take a look at the schematic and try and correlate where I can measure some voltages on this power supply board. And it would appear that something changes after a few minutes, maybe when something warms up. So what I need to do is find those test points and then get power on here and watch them for a few minutes to see if anything changes. So I'll just give you a quick look at the schematics that I'm using here, just to give you an idea. These schematics were available online. I just did a search for the model number, and there were a couple of sites that came up that gave the that allowed you to download them. They're in PDF format, and this is the schematic for the preamp, the digital signal processing, the A to Ds and D to As, this power supply section, or at least one part of the power supply section. And then there are two other schematics here. They both say amp module for L2 and amp module for B2. The amp module for L2 is for the stick, and the amp module for B2 is for the subwoofer, as I understand it. I found some errors on this schematic, and I'll show you what I mean by the errors. You can see that schematic there, and you see that it says line, neutral, and earth there. That's where the AC power comes in, and it goes through some chokes and some spark gaps and metal oxide varistors and so on, which is typical for these switched power supplies. And then it goes to a bridge rectifier here. The interesting thing about this is that the one side of the line goes to one side of the bridge rectifier, but the other side of the line, the neutral, is not connected in to the other side. You'll notice this line right here that goes down and comes to this MOV, and this side is not connected. It should be connected here. This part of the circuit here is the switch mode power supply. There's a transformer in the middle here, as per normal. There are there's the main FET in here, MOSFET, and then on the output side of the transformer, as in most of these switch mode power supplies, there are a number of windings, and there are rectifiers and filters and regulators. And so on the output side of this, there's VDD, there's VSS, there's VD, VS, there's a power supply that's called V drive and V drive 2. And there's a supply down here that says plus 18 volts out and minus 18 volts out. And so, and that's not all of them. In another part of the circuit, they take some of these voltage and regulate them down even further. So it's certainly complex enough. To recap, these two boards are both power supply and amplifier boards. The first board here is the power supply and amps for the subwoofer, and this other board, which is identical, is the power supplies and amp for the stick, for the column of speakers. And the problem that I have is in that amp for the speaker column. The subwoofer board appears to be working. I've put a signal in and I'm getting a signal out on the sub, which I've got concealed here under my bench. At some point in the process, and I don't know if this was something that I did or something changed, and I'm no longer getting that oscillation, but it's still not working. So I started looking at the power supplies, and I found that one power supply, which is actually a 10 volt power supply, was not working. So I did some troubleshooting on that, and I was able to find some bad components. I did a temporary fix because I didn't have quite the right replacements, but I was able to put in some components that I was able to get that power supply working. So where I'm at right now is that I have that power supply working again on this board. Now I'm going to check through it and see if all the other power supplies are working, and from there I'll then start signal tracing to see where I'm losing the signal and why it's not driving the output. So even though the parts that I ordered for getting that 10 volt power supply to work did do the job, they were not the correct package styles, and so I couldn't leave them like that. So the next thing I did was ordered the correct package styles, the actual correct part numbers, and they were going to take a couple of weeks, 2 to 3 weeks to come in. So I had to go on from there. As I said, the unit was not working. So at that point, neither one of the amplifier modules appeared to be working, and as I delved into it further, what I found was that the protection mechanisms that are built into this device were kicking in right away and stopping the signal from going through the circuit, and so it was hard to actually troubleshoot it. So I did further analysis on the circuitry and tried to figure out how all of this protection circuits worked. There were at least 3 different protection mechanisms. There was the Zobel circuit that was supposed to detect if there was too much power going to be drawn into the output speakers and would possibly damage the FETs, MOSFETs that were driving it, and if that voltage got too high it would cause a fault. As far as I could tell, that wasn't the case with this PA. There were other protection mechanisms. For instance, there were high temperature cutouts that used positive and negative temperature coefficient thermistors. There was another protection mechanism which was an overcurrent protection mechanism. And it was very difficult to test and troubleshoot that one. I delved into it further, got some information online, and found that the way that worked was the MOSFETs were being driven by a pulse width modulated signal. And during a certain narrow time frame during that signal, the current that was being drawn by the MOSFETs would be sampled and measured and sensed by the circuits on that board, and if they determined that the current was too high, it would send a signal to the unit and put it into a fault condition. I suspect that that was the source of the problem, but not understanding the circuit completely, I didn't know how to test that, and I couldn't come up with a theory of what would be causing it. So I was at a bit of a dead end. But I knew I had to get in those parts either way. Now, what I learned at this point in the process also was that Bose, for $250 US, including that shipping there and back, they will do the repair. And so at that point I began to think it would be best just to give the unit back to the customer and have him send it away. In the meantime, I also had this other identical unit that had come in, and I decided that I would switch over while I was waiting for the parts on the first one, and I would work on the second one, see if I could get it working, and then I might be able to use something from that to help me fix the first one, and if not, I would put in the new parts and I would give it back to the customer. So that brings me to the end of part one. In part two of this video, I'm going to show you the process that I took in fixing the second of these two Bose portable PA systems. Now, I was able to fix the second one. Unfortunately, this first one I wasn't able to. But I did learn a lot in the process of doing the first one. And I think that helped a lot in terms of troubleshooting and understanding what was going on in the second one. So I'd invite you to tune into the next video that'll be coming out very soon. And you'll see some of the things we learned and you see the successful conclusion, at least of the second one. So thanks for joining me on this one, and I hope you'll join in on the next one. If you would like to subscribe or give me a like, I'd appreciate that very much, and we'll see you all on the next one.